I think that discovery is the engine of progress.
We could come up with something in the field of science that could help with communications, phones.
If you decide you want to look at something you haven't looked at before, you've got to build a better telescope.
There's the possibility that there could be something amazing hidden in there, and as scientists, that's our job to figure out.
People were grappling in the 18th century, again with their sense of place in the universe. They were trying to figure out the distance to the sun, which is one of the most fundamental things you can measure in astronomy. In this day and age, we're still grappling with the same sort of problems, it's just that the scale has changed slightly. Whereas they were looking at the distance to the sun, we're now trying to weigh the entire universe. Why would we want to weigh the universe? Well, because there's a fundamental problem. If we look about the matter that we see in galaxies and stars, the stuff that you and I are made of, we think that roughly half of that stuff is missing. That is to say, if we look back to when the universe was roughly 4 or 5 billion years old, and we count up how much matter there was, it looks like half of it has disappeared in between then and now. Where's it gone? It's one of these joys of being an astrophysicist. You get into work in the morning and you think, well, what tough nut am I going to attempt to crack today? Fast radio bursts are millisecond flashes of radio emission. These things are releasing enormous amounts of energy in a millisecond. You know, the energy that the sun would put out in 80 years is coming out in a millisecond. There are a few thousand of these that go off across the universe each day, and we don't have a clue what they are. People think of space as being completely empty, but there are particles out there, and when the radiation from these fast radio bursts travels through it, it interacts with it. You look at the delay between the red and the blue part of the spectrum. Presto, you've got a measurement of the amount of matter encountered. If you know the distance to the burst, then you've just weighed the universe.
I think it'll probably lead to some of the greater technological advances in the next 50 years at least.
A great example of this is Wi-Fi being a ramification of wanting to observe exploding black holes.
20 years down the line, the pieces of that telescope end up in phones and computers, and it's all important for making the world a better place.
The universe provides the greatest pool of new things to discover. Obviously, you're going to be uncovering new things along the way.
Once we had activated the fundamental technologies that enable us to see emission on millisecond timescales, presto, within 3 days, there it was. This bright, booming burst came straight in, and it was at that point we realised we were sitting on a goldmine. We've got technology that enables us to do things that people simply have not been able to do before. And when you have that sort of technology at your fingertips, you can't help but make great discoveries. We do know what you and I are made of, but we can't find half of it. Where's it gone? Well, we think it's gone into that great vastness in between galaxies where it's very difficult to find. We're all part of the universe, so let's go and discover it.
I think it was when I watched Contact with Jodie Foster that I decided that radio astronomy is really what I wanted to do.
My sister wanted to be a princess. I really wanted to be an astronaut. And then I found out how much time you have to spend away from your family and friends and away from a good shower and stuff.
I was wanting to do computer science for a long time, and then my physics teacher told me that they're building this big telescope.
Having a scientist as a dad always pushed me towards learning more about the universe and how humans have just shaped the world to make our lives so much easier and better.